In this video, I'll start working on the front end. I'll do very little design work right now and will dive right into the SignalR and Axios functionality. But before I start up the IDE, I'll install Node.js. It comes with npm, the Node Package Manager, which I'll use to install all the packages that I'll need throughout the development of the application. In the usual fashion, I'll time-lapse this so you don't get too bored. Here you can see the Node.js version that I've installed. Then I proceed by setting up the project using the latest version of Vite. It will ask for the project name, framework and variant. I will write this front end in TypeScript. It's a little bit more work, but will improve the code quality dramatically. I move into the project folder and type npm install, which will start downloading and installing all the dependencies. Here you can see the project template with the typical rotating React logo, and here's the directory structure. Next is MUI or Material UI, a component library that I've been using extensively. I'll also install the MUI icons. Some people prefer Font Awesome, but this library is good enough for my needs. Then I installed SignalR for real-time communication, which is a core component and a must-have. I'll also install MessagePack, which is a protocol that makes communication more efficient. I install React DOM and React Router, which are definitely both needed, as well as Axios, which will help with making API calls. Then I install TailwindCss, which I have not used much. It is very powerful and decorating styles as classes sounds like a good plan. I'm following the Tailwind installation script here, which involves changing some config and CSS files to make it work. When running the project, it throws an error. I obviously overlooked some steps here. Let's try running the project again, and here's the template with TailwindCss. Let's put the IDE and website side by side to see what's happening. Just making the last changes to the Tailwind setup here, and we are in business. As IDE, I'm using Visual Studio Code, which is free from Microsoft. I have a couple of packages installed. One is ES7 React Redux Snippets, which has a few templates that help with quick code blocks. GitHub Copilot is my most trusted tool. I harness the power of AI to help me code. Prettier is a code formatter. TailwindCss IntelliSense help me find the right classes from Tailwind. And just like Visual Studio 2022, I used to do highlight here, to highlight when I still need to finish some code blocks. Next I import some logos that I have created in the first video. They will serve as logo on the page as well as fav icons, which show up in the browser tab. Here I start with a folder structure. Components will entail all the items showing up on the web page. One of the strengths of React is its reusability. Context will include anything that needs to be accessed from anywhere. Axios or SignalR handlers will be in here. Lib will contain constants, helper function, hooks, types, and other things that I can't think of right now. Package.json shows the packages that we have installed so far. This list will grow over time, but these are the most important packages that we will need. Next I go into the index.html page and change the title of the project. I also replace the fav icon. Then I remove all the content from the app.tsx file, which leaves me with a blank slate. Here you can see the power of Tailwind, just some class names are required. I go into the components directory and create 3 files, header.tsx, start.tsx and footer.tsx. They'll be the first building blocks of my front end. I use one of the React functional component snippets to create a quick code block for each file. So I just put the words header, footer and start in divs and save the files. Then I remove everything in app.css, which was still part of the React Vite template. Each of the components is styled in a very basic way at the moment. I want to focus on functionality and not design right now. So I use Tailwind real quick, and each component gets some colors and padding. Then I go back into app.tsx and import all 3 components into it. When I save, I get some errors, some text had snuck into it when applying the code blocks. I remove them and fire up the template. So far so good. Now I add some classes to the index.html file to make the page overall responsive and add to the title of the page. I remove the blue background and divide the text in the header into 2 code blocks. I want some text to the left and some text right aligned. I add some icons to the page so what I try to accomplish becomes more obvious. Here I create my first context, the socket provider. I define a constant socket context that is null at first but will be assigned as hub connection. Then I create the actual socketProvider function, which has child elements. The whole page will be child element to this provider. I hook into useEffect, which runs on startup to create a new connection to the SignalR hub on our API. The connection will use a message pack protocol, it will try to reconnect automatically, and I'll add some logging to the console for now. I hook into the connection start event to set the socket to this new connection. The catch block will catch any errors, and the return function will serve as cleanup for when the component dismounts. In that case, I want to stop the socket. I open the main TSX file, which actually surrounds the app TSX. Here I inject the socketProvider, so everything within the app will have access to the socket, which means every page on the site will make use of SignalR. Now I go into the header file and create some states to keep track of the connection and also create a timer. Again, I use useEffect that fires when the application starts. setInterval will run every second and increases a variable by 1 each time. Important here is the cleanup function, clearInterval, in the return statement of the useEffect. Otherwise, there will be more and more calls to this function stacking up every second. I create another useEffect that fires each time the counter or socket state changes. Here I check for the state of the socket and change a boolean variable accordingly. And I notice that I actually forgot to pull sockets from the context into this component. Copilot helps me fix a few errors I've made along the way. Then I use a boolean variable to change the connection status and color of the top right message. A green connection signifies a valid connection, a red disconnected will indicate that the connection to the server has been lost. Next I create a helper TS file in the lib folder. This will contain random functions that I'll need throughout the project. I copy a function from the web that converts an integer into a string indicating days, hours, minutes and seconds. I don't like the classic function call, so I convert it into a fat arrow function that can be imported easily. Going back to the header file, I surround the connection timer with this function, resulting in a much better representation for elapsed time. I also want to reset the timer when the connection drops or reestablishes itself, so I'm building that into the useEffect here. Now that the header has a connection indicator, I'm going to focus on the start component. I'm adding a button that fires a function when it's pressed. I'm also adding a text field next to the button. A use state called messages that contains a string array will keep track of incoming messages. Then I loop through the array using the map function, displaying each message in its own div. I add the socket from the context and add a use state that keeps track of the text field's content. In the sendMessage function, I check for the socket's connection and clear the text field after sending the message to the hub. Now I need to add an event handler that fires when incoming messages arrive. I'll make use of useEffect here, check for the socket connection and add the handler that adds the incoming message to the messages array. I don't have to do anything else. React notices a change in the array and displays the message automatically. I test out that new functionality and it works, so I open another browser window to see the action side by side. Notice there's absolutely no delay in the message delivery, it is truly real time. Now I go into the Swagger API to check out the endpoints. I want to test the API calls, which will be another important milestone for the project. I add a button and a type user to the component. Each user that comes from the API has an ID and a name. I also create another use state that keeps track of an array of users. Down below in the code, I loop or map over the users array and display each user with ID and name in its own div. And finally, I create a function that makes a call to the endpoint and is fired when the button is pressed. I'm using Axios get here, as it is a simple get endpoint. I keep it simple and don't add any error or dismount handlers or loading screens here. Finally, I add the function to the onClick handler of the button. After fixing a little typo in the endpoint, the page displays the 3 records currently in the users table. I notice that sometimes when the connection gets re-established, 2 or 3 duplicate messages will appear instead of 1. That is because event listeners are stacking up. Here in the else clause, I will rectify this error by removing the event listener when the connection drops using socket.off. After this implementation, the messages appear only once for each call. Now for some fun, I'll go into the API project and open the cron minutely class, which gets fired by quotes every minute. I use dependency injection here and add the socket context to the class. Then in the execute task method, I send a message to all clients every minute with the current server time. I forgot to include SignalR here in the class, and after publishing the project via FTP, the behavior on the page seemingly has not changed. But on top of every minute, we can now see the event on the server being fired, and messages being pushed to every connected client every minute. I have 3 browsers windows open so you can see how real-time the communication is. This will be the most powerful tool in our arsenal for the event management software we are building. As you have seen, sending and receiving real-time messages via SignalR is not only powerful, but will be a core component of our application. The list of server events that can trigger messages being pushed to clients or client groups is endless. Imagine email integration into this, where clients only have to respond with yes or no in an email to cause the system to react without user interaction. Or change in the schedule where the system knows if the user is online, pushes a notification on him, or sends an email if he is offline. It's this type of complete integration that offloads work from the event manager and brings an event management software to the next level. In the next video, we'll set up a few tables, create some DTOs and endpoints, and integrate tokens for authentication and authorization.